In this video, we will learn about discharging of RC circuit. Okay, let's consider a circuit like this. We have a capacitor and a resistor, and this is the voltage across the capacitor given by VC, and this is the current. Okay, the current in the circuit is IC. And we will plot what happens to VC and IC. Okay, for discharging, we have to assume initially the capacitor is charged. There's a initial voltage across the capacitor before discharge. Okay, and that initial voltage is given by V naught. Okay, so before we turn on the switch, the capacitor already have a initial voltage of V naught, and so the initial voltage is V naught, and when we turn on the switch, the capacitor will start discharging the voltage, the charge. Okay, so the current will flow. Initially the value here is V naught, and the current will flow, and this is the ground. Okay, so here the voltage is 0, ground, 0. So V naught to 0, there's a potential difference, current will flow, and as the current flows, the capacitor will start discharging. This V naught will slowly decrease. Okay, slowly decrease to 0. So that's the plot we'll get here. As time goes, the voltage will discharge until it becomes 0. Once it's 0, there's no more potential difference, so the current won't flow anymore. Okay, so the current, when we turn on the switch, initially current will flow. Okay, we have a finite current, and eventually the current will become 0 when the capacitor is fully discharged and there's no current. So it is something like this. Okay, but this curve is not very accurate. The reason is because we also have to consider the polarity of the capacitor. Okay, here this is the positive and negative, but the current flow is like this. Okay, in a load, the current should flow from positive terminal to negative terminal, but here it's flowing from negative terminal. You can see a current is going like this, from negative to positive. Therefore, we should plot it like this. To be more accurate, the plot should be like this. Okay, the initial current should be negative, and then okay, the magnitude will decrease to 0. Okay, the negative is just to indicate the direction is from negative terminal of the capacitor to the positive terminal of the capacitor. And what is the value of the initial current? We can use Ohm's law. The initial voltage is V naught, resistance is R, so this value should be V naught over R. Okay, so these are the plots shown here. Okay, this is the initial value of the capacitor. When it's being discharged, it will slowly discharge to 0, and the current will also, the magnitude of the current will also decrease to 0. Okay, the negative value here indicates the whatever I explained previously about the polarity. Okay, at any other given time, for example, if you want to know what is the voltage at this point, then we can use this equation. Okay, just replace the time, and R and C, and V naught is the initial value, and we will get the voltage at this point. Similarly, for the current, we can use this equation. Also, the other thing we need to notice is, just like charging, it takes 5 tau to become fully charged. For discharging, also the same, about 5 tau. Tau is the time constant, RC. The circuit will become fully discharged. Okay, that's all. Thank you.